Hello students, you are most welcome in the class of mathematics by N.K. Dikshit. Now, in the previous lecture, lecture 5, some particular type of questions were left. So, I am taking here to complete the exercise 7.4. So, integrals of some particular functions is continued. So, the question number 10 was in the exercise, that was find the integration of 1 upon within square root x square plus 2x plus 2 dx. So, first of all, we will make the quantity given in the square root a perfect square. So, it is the x square plus 2x. If we break this 2 as 1 plus 1, then we can see the quantity written in the bracket. This is the perfect square of x plus 1. So, we can write x plus 1 whole square plus 1 dx. Now we can use the formula that integration of 1 upon under root x square plus a square, that is equals to log of mod of x plus under root x square plus a square. So by using this formula, we can write it log of mod of x plus 1 plus under root x plus 1 whole square plus 1 plus a constant of integration, that is log of mod of x plus 1, and if we simplify the quantity written in the square root, then we can write it x square plus 2x plus 2 plus c. So in this way, by making perfect square, we can solve the questions easily. Now, for the same question, I am going to discuss the alternative method. This is the alternative method. The question is same, integration of 1 upon under root x square plus 2x plus 2. We have seen that after making perfect square, we can write it as 1 upon under root x plus 1 whole square plus 1. Now, if we are using substitution method here, and we substitute the value x plus 1 as tan theta, then the derivative of x, that is dx, is equals to sec square theta d theta. Now substitute these values. It is sec square theta d theta divided by under root. In place of x plus 1, we will write tan theta. So it is tan square theta plus 1. And you know 1 plus tan square theta is sec square theta. So it will be sec square theta d theta divided by sec theta. So we get integration of sec theta, and integration of sec theta is log of mod of sec theta plus tan theta. Now, because tan theta was equals to x plus 1, by the substitution, here we can see that tan theta, it was equal to x plus 1. Then we can find the value of sec theta also. Sec theta is equals to under root 1 plus tan square theta. It is 1 plus the square of x plus 1 So it is 1 plus x square plus 2x plus 1. After simplification, we get x square plus 2x plus 2. This is the value of sec theta. So place the values. It is x square plus 2x plus 2, and the value of tan theta is x plus 1. So in this way we can solve the question by this alternative method also. So in this way, by making perfect square, we can solve the questions. Now I am taking some other cases, like if a linear polynomial is given in the numerator and a quadratic polynomial is given in the denominator, either in the square root or without square root in the denominator. So if in this form the question is given that p, q, a, b and c are constants, in these cases we have to find a capital A and a capital B such that px plus q means the numerator of the question is equals to a times of derivative of denominator, or if a quantity is given in the square root means that is the quadratic polynomial plus another constant b. After comparing, we can find the value of a and b, and then by placing the value of a and b, we can split the question into different parts and easily we can solve. So to clarify this, I have taken one example, that is integration of 5x minus 2 divided by 1 plus 2x plus 3x square. Here in the numerator a linear polynomial is given and in the denominator a quadratic polynomial is given. So we have to identify two numbers a and b such that the numerator, that is 5x minus 2, it is equals to a times of derivative of the quadratic polynomial given in the denominator, 1 plus 2x plus 3x square and plus the constant b. So 5x minus 2 is equals to a, the derivative of 1 plus 2x plus 3x square, derivative of 1 is 0, 2 times derivative of x is 1 plus it is 6 times of x plus b. So 5x minus 2 is equals to 2 is common, so 2a 1 plus 3x plus b, and 5x minus 2 is equals to 2a plus 6ax plus b. You can write as 6 times ax plus 2a plus b. Now compare the coefficient of x. Then coefficient of x is here, it is 6a, and coefficient of x is 5. So on comparing, we get 6a equals to 5. It implies that a is equals to 5 upon 6. This is the value of a. Now to find the value of b, take the constant term. It is 2a plus b here, and it is equals to minus 2. Value of a we have already find. It is 2 times of 5 upon 6 plus b equals to minus 2. So cancel out. So 5 upon 3 plus b, it is equals to minus 2. So b is equals to minus 2 minus 5 upon 3, that is equals to minus 11 upon 3. This is the value of b. So we get a equals to 5 upon 6 and b equals to minus 11 upon 3. So The question was integration of 5x minus 2 divided by 1 plus 2x plus 3x square. We have changed the numerator replaced by this quantity 5x minus 2 can be replaced by a d over dx 1 plus 2x plus 3x square plus b, and we have the value of a and b. So we can write a times means 5 upon 6 times of derivative of denominator, and that was 2 plus 6x plus value of b, that is minus 11 upon 3 divided by 1 plus 2x plus 3x square dx. Now separate these two terms. So first one is 5 upon 6 integration of 2 plus 6x divided by 1 plus 2x plus 3x square dx, and second term is minus 11 upon 3 integration of 1 upon 1 plus 2x plus 3x square. So what is the reason for the substitution of these a and b? The reason behind it, if the derivative of denominator is given in the numerator, then numerator can be taken as t, then denominator becomes dt. So easily we can integrate 1 upon t dt, that is log of t. So here we have two integrations, one is taken I1 and second one is as I2. This is 5 upon 6 times of I1 and 11 upon 3 times of I2. So I1 is integration of 2 plus 6x upon 1 plus 2x plus 3x square, and I2 is equals to integration of 1 upon 1 plus 2x plus 3x square. So I1 is equals to 2 plus 6x upon 1 plus 2x plus 3x square. Here if we take 1 plus 2x plus 3x square as t, then the derivative, it is 2 plus 6x dx is equals to dt. So it becomes dt divided by t, it is log of t plus c, it is log of mod of t, and the value of t is 1 plus 2x plus 3x square. So this is the integration of first term, it is I1. Now to solve the value of I2, I2 is equals to 1 upon 1 plus 2x plus 3x square. 1 upon 1 plus 2x plus 3x square. First of all, the term which contains x square make the coefficient 1. So for this, we have to take 3 as common. So when 3 is taken common, we get 1 by 3 plus 2 by 3x plus x square. Now we want to make perfect square of x square plus 2 upon 3x plus 1 upon 3. So it is x square, then 2 times of x into 1 by 3. So we required a term square of 1 by 3. So add this term, and to balance this, 1 time subtract this term. So we get the perfect square of x plus 1 upon 3 and plus 1 upon 3 minus 1 upon 9 x plus 1 upon 3 whole square plus it is 2 upon 9. So we can write in the denominator integration 1 upon it is the square of x plus 1 upon 3 plus the square of under root 2 upon 3. 2 upon 9 can be written as the square of root 2 upon 3. So it is the form of 1 upon x square plus a square. So we can use the formula 1 upon a. So 1 upon a, the value of a is root 2 upon 3 here. And tan inverse x upon a, the x is x plus 1 upon 3 and a is under root 2 upon 3 plus constant of integration, that is c. So it is 1 by 3 into 3 by root 2 tan inverse it is 3x plus 1 upon 3 divided by under root 2 upon 3. So here 3 cancel out, here also 3's cancel out plus c. So the value of I2 we get 1 by root 2 tan inverse 3x plus 1 upon under root 2 plus c. Now we have to combine these terms. So in the first integral we are taking the constant as c1 and in second one we take constant as c2. So after combining these constants we will write a new constant, that is c. So the I is equals to, it was 5 upon 6 I1 minus 11 upon 3 I2. So it is 5 upon 6 I1 minus 11 upon 3 I2 plus the value 5 upon 6. The value of I1 is log of 1 plus 2x plus 3x square, log of mod of 1 plus 2x plus 3x square plus c1 minus 11 upon 3 times the value of I2 is 1 upon root 2 tan inverse 3x plus 1 upon under root 2 plus c2. Now there are two constant terms c1 and c2. So combine these two terms and write a new constant, that is c. So the final answer is 5 upon 6 log of mod of 1 plus 2x plus 3x square minus 11 upon 3 root 2 tan inverse 3x plus 1 upon under root 2 plus c. So in this way we can find the solution. It is a very important question. Remember the point. Which type of substitution we have to do here? These are the main points. How to find the value of a and b and what is the benefit you can observe from the solution, because if we are taking the derivative of denominator, then the first term integration is very simple and in the second term in the numerator we get a constant. So to solve this integration second part, we have to make a perfect square and we can use the formula which we have studied. So in this way we can solve these type of questions. Now you can solve all the questions of the 7.4 exercise. Now in the next lecture I will take how to solve the questions of integration using partial fractions. So by using partial fractions we can solve the questions. We will discuss later. Okay, thank you.